All right, we are on week 4 now. We are still looking at linear functions. First, we're going to look at a table here. This was taken directly from a college algebra textbook. This just goes over a few things about linear functions, a little explanation, and a few examples of them. So, again, things like linear equation. We usually think of a linear equation as something that can graph a line. There's a specific form that you can write it in. So if you can get your equation into this form, a times x plus b equals 0. And of course your a cannot equal 0. We don't want 0 times x because that basically just cancels out and it would say b equals 0. Okay, so if you can get it into this form, then it would be considered a linear equation. So like 4x plus 5 equals 0, that's technically linear. Even though it doesn't really have a y, we can usually kind of think of this 0 as taking the place of our y. Then 4x plus 5 equals y. That would be a linear equation. It makes a line. But again, this is the form, this ax plus b equals 0. That's considered a linear equation with just one variable, that x. The addition property, so if you take a equals b and you just add c to both sides, a plus c equals b plus c. Okay, this is the same reason why we can take something like x minus 7 equals 25, add 7 to both sides, minus 7, add 7, those kind of cancel out, and we just get this x equals 32. The reasoning behind the fact that we can go from this equation to this equation is called the addition property. It just allows you to add to both sides. Basically, it just means you can add you add the same amount to both sides of the equation, add over here, and you didn't change the truth of the equation. It's still a true statement. Multiplication property is the same. Instead of adding, you're multiplying the same amount to both sides. And again, on this one, there's kind of the caveat that c cannot equal 0. If you multiply both sides of the equation by 0, well, you just zero everything out anyway. So again, we're just saying you can multiply the same amount to both sides. It doesn't change anything. So like half x equals 4. Multiply both sides by 2. Well, 2 times a half would just be 1, so it's just x over here. So then x equals 8. So again, multiplication allows you to multiply to both sides. Distributive property, again, just allows you to distribute. If you're multiplying kind of a coefficient like this a times an entire group, you would just distribute it or multiply to each piece on the inside. Same if there was a subtraction here. You just kind of distribute it out. An identity. So these three, identity, contradiction, and conditional equation. There aren't really any good, there's not a whole lot of good homework problems, so I'm going to do the best I can to give you some practice, but I do want you to know these three things: an identity, a contradiction, and a conditional equation. These are all different kinds of equations that will equal something different in the end. So an identity is described as an equation that is true for all meaningful values of the variable. So again, like if we have 3 times the amount x minus 2 equals 3x minus 6. Well, again, we can see that these are equivalent to each other. This is something because of our distributive property. You can distribute this 3 and it does in fact equal this. Basically, if you were to simplify this equation, you would end up with x equals x. And of course, that is going to be true. If I plug in 1 over here, it equals 1 over here. If I plug in negative 7 right here, it equals negative 7 right here. So basically, an identity is any time you can get it to say x equals x in the end. A contradiction, on the other hand, is a different kind of an equation. It's an equation that has no solution. So notice, like if we have x plus 5 equals x, well, there's no such number that if you add 5 to it, it'll come back to that number. If we were to subtract x from both sides, we would have 5 equals 0. And that's definitely not true. So basically, if an identity can be reduced down to x equals x, a contradiction can be reduced down to some number equals some other number. That is definitely not true. 5 does not actually equal 0. If you got it to say negative 3 equals 1, again, that would be a contradiction because that is not actually true. Same thing over here. 2x minus 2x equals 5. Again, 2x minus 2x is just 0. So 0 equals 5. That is not true. If it ends up being an untrue statement, contradiction. The last one is called a conditional equation. It is an equation that is satisfied by some but not all of the values of the variable. So basically, these are the ones you can solve. So like 2x minus 1 equals 5, add the 1 to both sides. 2x equals 6, divide by 2 from both sides. And then x equals 3. So if in the end you get x equals some number, we don't know what it is, but whatever you solve for, that is called a conditional. This is the true condition. This equation only works under this condition. This equation works under any condition. X can be anything. This equation works under no conditions. It is not possible for this to ever work. So identity, contradiction, conditional. Last thing is just kind of going over percentages. I'm not really sure why they added this in there, but again, this is just how you find a percentage. If you want a percent of x, you put that percent over 100 multiplied by x. So 75% is like 75 100ths of whatever number you're getting. Solving the distance between points. When we're solving the distance between points, we can think of it as the Pythagorean theorem. So Pythagorean theorem, remember, only works for a right triangle with sides A, which I've done in blue, B, which I've done in red, and C, which I've done in green. If you want to find this green side, also known as the hypotenuse, you take the two legs, A and B, you go a squared plus b squared equals c squared. That would be the Pythagorean theorem. We'll notice that if we're going from one point to the next, we can almost kind of draw in. Here is my horizontal distance up to this point. Here is my vertical distance up to this point. And together, those would create this diagonal distance. So, kind of like how we can use the Pythagorean theorem on a right triangle, here we're just creating a right triangle for us to solve. So again, it's the horizontal distance squared plus the vertical distance squared will equal our total distance squared. A squared plus b squared equals c squared. And that's how we can find that distance. So, how would we find this horizontal distance? Well, we just take the x value of one of them minus the x value of the other one. Right? So this x value up here is 1. This x value down here is negative 3. It's real easy to see on the graph here that they're 4 apart. 1, 2, 3, 4. Instead of having to count it out though, you can also just use those actual x values, subtract them, that gives you the horizontal. Similarly, you can subtract the y values, 4 and 1, to find this vertical distance of 1, 2, 3. So here is 3, here is 4. So again, horizontal distance squared plus the vertical distance squared equals our distance squared. You can simplify that by saying the second x value minus the first x value squared plus the second y value minus the first y value squared equals our distance squared. Now in the end, we don't want our distance squared, we want distance alone. So to get rid of this, if we don't want to have that squared, we take the square root of this other side. So this is probably the most basic or the most simplified distance equation or distance formula that you might find. D, or distance, equals the square root of all of this piece, x2 minus x1 squared, plus y2 minus y1 squared. All of that is underneath the square root, and that would be your distance. So in our case, if we're looking at these two, we've got this point over here at negative 3, 1. This point up here at 1, positive 4. Sorry, that's supposed to be a 1. So we just plug these in. X value of the second is a 1, minus x value of the first is a negative 3. and it'll be squared. Plus y value of the second is a 4, minus y value of the first is a 1, and that'll be squared. Everything is underneath this square root. When you're minusing a negative, 1 minus negative 3, it's like you're adding. 1 add 3 is 4. So we have a 4 squared. Plus 4 minus 1 is 3. So we have a 3 squared, and again, all underneath that square root. I have to extend this a little bit. 4 squared is 16. 3 squared is 9. Still under the square root. 16 plus 9 is 25. So you can leave it as root 25, but actually what you're usually supposed to do is either reduce this and say, well, this equals exactly 5, or round it. Let's say it was something like the square root of 27. Well, then it would be 5 point whatever, probably out to 3 decimal places. Or if you can simplify, let's say it was something like the square root of 50. Remember, we can simplify our radicals by splitting this up into square root of 25 times the square root of 2, because 25 times 2 is 50. This one we don't know the square root of. This one we know is 5, so it would be 5 square roots of 2. This is probably the best way to say it. If you can get it into this form, put it this way, unless the question says leave it as decimals and round it. But otherwise, this is your best form. In our case up here, 4, 3, and 5, that is called a Pythagorean triple. We know that this one has to be 5 because we have 4 and 3. So this one would just come out to a simple 5. The midpoint between 2 points. If we want to find the exact center, so I'm going to use these same 2 points. Negative 3, 1 is our first point, and 1, 4 is our second point. We want to find what is in between them, where the exact middle between these 2 points is. Well, the trick is you average the x and you average the y. So, x values, negative 3 and 1, we add those up. Negative 3 plus 1. To find the average, you divide by however many there were. There are 2 of them. Average the y values, 1 plus 4. Again, divide by 2, because we're finding the average. Average x, average y. Negative 3 plus 1 is a negative 2, divided by 2. 1 plus 4 is 5, divided by 2. So this average x value looks like a negative 1. Average y value, you can leave it as 5/2. You can reduce it to 2.5, or maybe in this case makes a nice easy decimal of 2.5. So we can say that the midpoint between them is at negative 1, 2.5. Now let's see exactly where that is on the graph. Negative 1 and up 1, 2.5. This, we can even kind of see it too. This is our exact center. That is the point that is exactly halfway between both of them. And again, we found it by taking the average x and the average y. That'll do it for this video.